Hello there guys, welcome back to another C# tutorial. In this tutorial we will see how we can rearrange elements in an array. So uh, by rearranging elements we mean, for example, if you enter the values 1, 2, 3, maybe you want to reverse them to be 3 to 1, or maybe uh, you know uh, uh, sort them or do something like that. So we will start with the very basic thing, and we will continue uh, based on that. So the very first thing we're going to try is to reverse the reverse the elements in an array. So how we are going to do that? Well, we will start with the easy thing here. So we have this is going to be static void, or maybe let's say int reverse int numbers. Okay, so we are going to write a function called reverse, which will receive an array and return another one that is being reversed. So how do we do that? Obviously we need to define the new array. So int v equals new int numbers dot length. Simple. Next we need to copy the elements. For int I equals 0, is more than numbers dot length and I plus plus. Now in the previous code, when we copied an array, we wrote something like this: v of I equal numbers of I. What that means, the first element goes at location 0 goes into the new array at location 0, and the element at location 1 goes to the element at location 1, the new array, and so on. Now we don't want that to happen. We want the first element to be the last, the next element to be the one before, and so on. So one easy way to do it is int j equals numbers dot length minus 1. Okay, and we use minus 1 because the indices starts from 0 up to the total number of elements in the array minus 1. Okay, so when we say we have 10 elements in an array, the first element number is 0, the last one is 9. Okay, so this is fine. Now we will say v of j equals numbers of I. Now if you leave j as it is, j doesn't change. So when I changes, as you can see here, j will still be pointing to the same location. So you need to tell the computer what to do after the copy process, or basically we would decrease j. Okay, make sure to put the minus minus after j, not before j, because you want to decrease and then you want to copy and then decrease the value of j. Okay, or maybe to make it a little bit more clear, j equals j minus minus. Okay, it's as simple as that. When this one finishes, we are gonna say return v, right? So now let us try this out. I'm gonna say this would be reverse v print array w. Okay, so let us run this code. Okay, so I can say 1, 2, 3, 4, 5, and you can see we have 5, 4, 3, 2, 1. Okay, it's very simple. Maybe we run this again into different. Okay, you can see 1, 3, 6, 6, 4, and 2, which is the reverse of the output. Okay, now let us improve on that. So what kind of improvement can we do here? Well, if you have a look here, what do we do? What have we done? We defined a variable which is j, and we use that and we decreased it. If you don't want to define an extra variable, we could do the following. You could remove this one and use this format. Okay, so here things are a little bit more complicated. So what's happening here? Well, numbers.length minus 1 by itself gives you the location of last element. Now, when you subtract I from that, what happens? For when I is 0, you will get from here the very first element. Now, this gets you the last location. Minus 0, you will still be pointing to the last location. So the first element goes to the last one. Next, when I is equal to 1, uh, this will get you the last location minus 1. So this term will get you to the location of not the last, the one before. When I increases, you get the one before, and so on. So the difference between this format and the one before is that we didn't use an extra variable. Okay, let us run this and see if it works. So 1, 2, 3, 4, 5. You can see it is reverse. The code is reversing the elements correctly. Okay. Now, this is the first method to reverse the arrays. But what we had to do here, we needed to make a copy. What if you want to reverse the array such that you you use the same storage? So you reverse the content of the same array. So how do you do that? I'm going to say static void reverse 2. I'm going to call it n to make things a little bit easier. Now, the thing we need to know, or one of the things we practiced before, is swapping variables. So when you are reversing an array, let's say you have an array that is that contains the element, let's say 1, 2, 3. Let me write this: 1, 2, 3, 4, 5. So what happens? Well, you could do it like this. You swap the first element with the last one. So what happens? You get 5, 2, 3, 4, and 1. So we swap this one with this one, right? Next, what you do, you swap 2 with 4. So you end up with 5, 4, 3, 2, 1. And it finishes here, because if you want to, let's say you take 3 and try to swap it with itself, it's the same 3, so you end up with this, right? So as you can see, this how many swapping did we do in this example? We did 2 or maybe 3 if you take 3 as another swapping process. Okay, so it's half half the number of elements in the array. So we are going to try to do that. So you have a loop for I and I equals 0, I smaller than n dot length. Now n dot length minus 1. What we are going to do, you divide this by 2 and I plus a plus. Okay, so how do you swap an element? If you remember from previous code, you take a temporary temp equal n of I. So far so good. Now n of I equals, now this one will be you will get a copy of the element from the end. So n of n dot length minus 1 minus I, okay, and n of n dot length minus 1 minus I equals tmp, right? So you put this one here, you put this one here, you put that one into here, okay, and that's it. This is the whole process. This will reverse the whole array. So let us try this out. I'm gonna say reverse 2. Hopefully it's gonna work. Let's see. I'm gonna say 1, 2, 3, 4, 5, and it is working. 5, 4, 3, 2, 1. Magic, right? Well, it's not magic, it's logic. So maybe you might want to increase the number of elements. Let's make them 7 or maybe 8 to have an odd number. So 10, 20, 30, 44, 55, 66, 87, 88, and you can see the 876. Oh, wait a second. Oh, as you can see here, there's an error. Okay, so maybe I need to, yeah, I don't have to perform a -1 over here. Yeah, a mistake. Let us try this out again. 3, 4, 5, 6, 7, 8, 8, 7, 6, 5, 4, 3, 2, 1. Okay, now it is working correctly. And the reason for the previous error is that when I put -1 and then I divide by 2, I have what? I have 7 divided by 2. This results in 3.5. Since this is C#, integer divided by an integer would result in an integer. So instead of using of looping from 0 to 3, the loop became from 0 to 2 because the 0.5 was ignored, right? So here you just you don't have to put a -1 over here. This was my mistake. Okay, so we have seen how we can reverse the element in an array using two methods. The first used an extra array, an extra storage, and the second used the same array. So far so good. Now let us do something that is a little bit more interesting. Let us, for the sake of example, what if you want to, well, swap each consecutive elements? Okay, we want to swap each two elements in an array and see what happens. Okay, static void swap elements int n. So there's no big idea behind this. This is just a test. I want to show you how to do things again and again using arrays and see what happens. Later on, some of these ideas might be used. For example, this one will help you when you try to do sorting. Okay, so what are we going to do here? We're going to say for int I equals 0, I smaller than n dot length -1 I plus plus. Now I put a -1 here, although there's a smaller than sign, because we want to swap the first with the second with the third, and so on. The last element cannot be swapped with anyone because, you know, it is the last element. So here, what are we going to do? We're going to say int tmp equal n of I, and n of I equals n of I plus 1, and n of I plus 1 equals tmp. Okay, it's as simple as that. So now let us try this and see what's going to happen. I'm going to say swap elements. Okay, so let us write this. I'm going to say 1, 2, 3, 4, 5, 6, 7, 8. So what do you see? You can see that 2 gets to the you know, all the elements are shifted and 1 becomes the last element. So if you think about it, when you swap the elements in order from the first location to the last one, what you are doing, you are shifting the elements in the array. Okay, This is one way to think about it. Or if you think about it in a different way, you are moving the number and the first element inside the array. Okay, so here what happens, we moved, you could think about it like you tried moving the element 1 in the array. So to visualize this a little bit uh, and to see what's happening, we are gonna do the following. We are gonna modify this code. We're gonna say system console dot write line. Okay, so we will put an empty line, and then what are we gonna say? We are gonna say print array. We will pass n. So after each swapping process, we will print the array to see what's happening. So we are gonna run this now, and I'm gonna say 1, 2, 3, 4, 5, 6, 7, 8. Okay, so a number of things happened here, but let us go to the very beginning. There we go. Okay, so what do we have here? Can I make this a little bit smaller? Okay, it can. That's wonderful. So after the first swap, you can see now 2 becomes the first element and 1 shifts down to be the second, right? The rest is still the same. In the next step, you see that 1 and the 3 get swapped. You can see them here. In the next step, you can see 1 and 4 get swapped, as you can see them here and here. Okay, and in the next step, you can see that 5 and 1 get swapped, and then you can see 6 and 1 get swapped, and you can see 7 and 1 get swapped, and in the last pass you can see that 8 and 1 get swapped, and the repeated result is because we are calling the print command in main. Okay, so you can see what's happening using this very simple technique. Okay, so now we have seen how swapping elements works. Now the order of swapping also could affect what's happening, right? So here we are going to change the code a little bit. We are going to start from here, from the last element, and we will decrease the value of I. Okay, so we'll start from the very last element and decrease the value of I. So what's going to happen? So if we run here, I'm going to enter 1, 2, 3, 4, 5, 6, 7, and 8. Oops, obviously I did something wrong. Yes, I did. Yeah. So sorry. Obviously I forgot to change these indices. Very sorry about that. Okay, because this one is the last element, and yeah, we are moving backwards. Okay, so let's try this. I can say 1, 2, 3, 4, 5, 6, 7, and 8. Okay, so what we end up with is that the last element becomes the first. Or if you would like to think about it in a different way, you shifted all the elements downwards. Okay, you shift all the elements downwards. Okay, so let us see what's happening here. So the first pass, you swap the last element with the one before, right? So you move 8 up. In the next pass, you swap the one before with 8 and 6, and then later on you will swap 8 and 5, and then you will swap the 5 and 4, and so on. So at each step 8 is being swapped again and again and again and again, and because of that it looks like it's moving forward. Okay, so there is not well, this is not a very productive technique of doing things, But the reason I'm showing you this is because this one or this method is used in order to in sorting. So we are going to modify this a little bit and see how we can take advantage of it using a simple if statement. So here, swap elements 2. Now, let us assume that we put a condition here, that is, we don't swap elements unless they are not ordered. So that means if n of I, okay, is greater than n of I minus 1. Let me put one the way it used to be, okay, and I is smaller than, and length, and I'm gonna say I plus a plus. This is how it was, right? Okay, and C and I plus 1. Never mind that. Okay, there's a plus here and there's a plus here. Okay, so check this out. This condition tells that there are 2 consecutive elements in the array, and the first element is greater than the second. If so, then swap them. Okay? So now, this simple swapping technique, we will just put this condition. So it will not always swap, it will only swap when the elements are not ordered. So let us see what happens. I'm going to run this now. I'm going to say 1, 2, 3, 4, 5, 6, 7, and 8. Okay. So what do we get here? Wait a second. Oh, I forgot to change the call. Yeah. Okay. So I won't enter the values from 1 to 8. I'm gonna enter them randomly. So 9, 4, 6, 3, 2, maybe 56, and 3, 23. So check this out. The maximum value here, which is 56, is now the last value, and the next is 23, right? So let us try this again. We are gonna say 99, 3, 6, 4, 9, 3, 5, 8. So what do you see here? You see that the value 99 is the last value, okay? And if we go and trace the code or see the result, you can see that in every step, sorry, let me just move this one here. Okay, so check this out. So in the first step, 99 was pushed down once. In the second step, 99 is also pushed down. In the next step, 99 is again pushed down. In the next step, it got pushed down again. And now it's almost near the end, and now it is the last element. So using this very simple condition resulted in pushing the largest value in the array down. Now you might be wondering, why do I need to know this? Well, basically, this is the basic idea behind bubble sort. The idea of bubble sort is very simple. If you apply this technique and again, in the first pass, what will happen? You will get the first largest element at the end. If you run it again, you will get the next largest element before that. If you run this technique again, you will get the next largest element, and so on. So what can we do here? Okay, I will delete this part here. I will make a method. I will call it sort static void sort. Okay, so I'm going to say for int I equals 0, I is more than n dot length and I plus plus. Okay, you might be wondering why n times. Well, it's not n times, it's less than n times. But basically, if you have, let's say, 10 elements, the first pass will get the first largest element to the end. The second pass will get the second largest element. The third pass will get the third largest element, and so on until you get to the very last element. Okay, so this is not exactly how bubble sort works, but it's similar idea. Swap elements 2. I'm gonna say n, and we are gonna call this sort. Okay, so now let us run this code and see if it works. I'm gonna say 99, a very big number, and 73, 8, and maybe something in the 60, 23, whatever. Check this out. You get all the elements sorted. Okay, so what happened in the code is that the first pass got 99 to the end. The next pass got 73 to the end, and so on. And we can actually add a little bit of code over here. We can say print array and system console write line. Okay, just to see what's happening. Okay, maybe we would say pass. Basically, they call this pass these passes. Each time you iterate on all the elements, they call them passes. So the first pass, second pass, okay, which means the first time you scan all the elements, the second time you scan all the elements, and so on. Okay, so we can see the passes and see what's happening. So let's run this. Let us run this out and see what's going on here. I'm gonna make this a little bit smaller. Okay, and now we will enter the values 92, 2, 85, 3, whatever. Da, t, boom. Okay, so let us see. Okay, so pass 0, which is the first pass because we're starting the loop with I. So the first pass, what do we get? What is the largest element? It is 734. You can see that it's at the very end. Okay, very interesting, right? But also you can see that 99 got pushed into the middle. So what's happening is that the computer, when it is searching for when it's performing the swapping operation, it will keep swapping 99 until it reaches a number that is larger than 99. Okay, and this is at the fourth location. So you can see at location number 4 it's stopped, and then swapping of 754 and 74 starts. So you can see sorry, yeah, okay, so we got here. So the next pass, the second pass, what do we get? We get the second largest number, which is 289. Okay, same technique applies. And the third pass, what do we get? We get the third largest number, which is 99. The next pass we should see 74. And if we have a look, you can see 74 over here. And if we have a look again, what do we see? You can see 45. Okay, so you can see now it's already sorted, but our technique is kind of lazy, so it keeps checking even though we already sorted the values using 4 passes. Okay, but anyway, this is the basic idea of bubble sort, but this is not the accurate bubble sort. Okay, so the video just stopped for a second. Anyway, so again, as I said, this is the basic idea behind bubble sort. uh, I hope you find this tutorial useful. uh, we will keep practicing a little bit more on arrays. uh, Thank you for watching, and have a nice day. Bye bye.